Please see the link in the description to download a worksheet for this video. Experiments can be dangerous. If you are a child, never do experiments unless your parent, guardian, or adult educator says it's all right and is there with you the whole time. This is the fourth video in a series on the scientific method and is a review of the content presented in the prior 3 videos. Unlike the prior videos, the format for this video is to ask you questions first, then give only brief explanations with no memory tips. If you have not already done so, we suggest that you watch the first 3 videos in this set before watching this video. In this video, we will do 2 experiments with electric magnets, similar to this one. We will change this design to see how any changes we make will affect the magnet's strength. We will measure the magnet's strength by seeing how many paper clips it can pick up. Before we begin the first experiment, let's review a little information on magnets. There are 2 common types of magnets: permanent magnets like this bar magnet, which are always on, and electric magnets, such as attached to this crane, which can be turned on or off by switching the electric current on or off. An electric magnet is made of 3 parts: a power source, such as this battery pack, a central rod, and a wire that wraps around the rod and connects to the power source. The switch is optional, but we use this for safe handling. To make an electric magnet, we wrap the wire around the rod, then connect the wire to the power source via a switch. When making an electric magnet, we have many options, including how strong the power source is, what the rod is made of in addition to its shape, the type of wire we wrap around the rod, and how many times we wrap the wire around the rod. Before we begin our first experiment, please summarize the steps of the scientific method. The scientific method has at least 4 steps, which you may wish to remember with the word data. When we expand these 4 words, we then get 4 sentences which describe the basic steps. Let's say we're wondering, how does an electric magnet's strength change if we switch its iron rod to be a non-iron rod? Please write a research question. Here is an example of a research question we can use. Does an electric magnet with a non-iron rod have the same magnetic strength as one made with an iron rod? Please note that unlike the prior question, this one has a yes or no answer. The second step of the scientific method is to arrange the research question into a hypothesis. Please arrange this question as a hypothesis. A hypothesis arranged from our research question is an electric magnet's strength depends on what the rod is made of. A hypothesis is a statement, not a question. It is the guessed answer to the research question. If possible, we include the word depends. We'll be using this electric magnet as the control. Its rod is made of iron. Which of these rod options should we use for the experimental magnet? Answer C is wrong because we need a non-iron rod. Aluminum and steel are both good choices for this experiment, but we can only use a rod that has the same shape and size as our control rod, because our hypothesis is focused on how a magnet's strength is affected by what the rod is made of, not by the rod's shape or size. Among the choices, only option A is the same shape and size as the control but made of a different material, so answer A is correct. For example, option B is a threaded rod with a smaller diameter than the control. Option D is a longer rod than the control. So if we used options B or D in our experimental magnet, and got different results for its strength than with our control magnet, then we would not know if the reason for the difference was due to the rod's size, shape, or the material it's made of. Which of these wires should we use for the experimental magnet? The control magnet is made using option A. The correct answer is option A. The reason is because our hypothesis is focused on how the magnet's strength is affected by what the rod is made of. The word composition is another way of saying what something is made of. The rod's composition should be the only difference between the control magnet and the experimental magnet. That means we need to use the same wire with the experimental magnet, as we use with the control magnet. Which of these battery sources should we use for the experimental magnet? The control magnet is made using option A. Option A has 8 batteries and generates 12 volts. Option B is 6 volts and option C is 3 volts. The correct answer is A. The reason is because our hypothesis is focused on the impact of the rod's composition. The rod's composition should be the only difference between the control magnet and the experimental magnet. That means we need to use the same amount of power for both magnets. On a test, you may be asked to identify the type of variables used in an experiment. For practice, please list the variables in this experiment as independent, dependent, or controlled. Now that we've designed our experimental magnet, so it is identical to the control one except for the composition of the rod, we're ready to test it. We find that a magnet with an aluminum rod lifts no paper clips, whereas the control magnet with an iron rod lifted 7 paper clips. Which type of graph should we use to plot this data? Although we know the number of paper clips each type of magnet lifted, that is the only number associated with each magnet. So our only option for plotting this data is to use a bar graph. The values for the independent variable are written on the horizontal label, and the values for the dependent variable are written on the vertical label. On a state exam, we enter this data by clicking on the top of the box, then lifting it to the correct height, which is 7. To complete the scientific method, we would then publish our findings in a research journal. For our second experiment, we want to research how an electric magnet's strength changes if we change the number of wire windings around the rod. Please write a research question. Here's a research question we could use. Does an electric magnet's strength change if we change the number of wire windings around the rod? Next, please arrange this question as a hypothesis. Here's one we could use. An electric magnet's strength depends on the number of wire windings around the rod. This is our control magnet. It has 40 windings. It picks up 7 paper clips. This is our experimental magnet with 30 windings. It picks up 6 paper clips. This is our experimental magnet with 20 windings. It picks up 4 paper clips. This is our experimental magnet with 10 windings. It picks up 0 paper clips. Here is a summary of the results. Would you use a bar graph or a line graph to display this data? We encourage you to sketch what this graph should look like. Unlike the prior experiment, in which the values for the independent variable were words, such as iron and aluminum, rather than a number, in this experiment the values for the independent variable are numbers, so we can graph the data using a line graph. Although we could use either a bar graph or a line graph, we use a line graph whenever it's possible. For each point, the x value equals the value of the independent variable, shown in green. The y value equals the value of the dependent variable, shown in red. The x-axis has a multiplication factor in its label, so the lines on the x-axis are 10, 20, 30, 40, 50, 60, and 70. We plot each row of coordinates in the same way that we would graph a point with an x and a y coordinate. We can see a trend that as the number of windings increases, the electric magnet can lift more paper clips. If this was a real science experiment, then we would complete the scientific method by publishing the results. Here's a summary of the topic we just covered. Please pause the video to read this if you wish. If you're interested in practice tests that are similar to state exams, but with detailed, colorful explanations for each answer, then please see our apps in the App Store. Many of these are free and none expire or limit their function. Since we only make educational products for children, none of our apps have third-party advertising, in-app purchasing, or connect to the internet. Please subscribe if you'd like to be notified of future educational videos we make. Thanks for your attention.